So I lost the race from the computer. So let's finish this problem and then move on. Hopefully you're able to get that on your own. But if not, I do want you to make sure that you still write that the A is in front. Because what might happen is we might stretch this out. There's really no way of answering this unless I told you what the y-intercept would be, which I do not do. So you can't really figure out what A is in this problem. So as I move on, I can also give you clues and a table, and just make sure you read the directions. Like, don't just jump into the problem. Identify the left and right end behavior. You could actually answer this without knowing it's a quintic polynomial, but you could confirm that it's at least an odd degree based off of the end behavior being the opposite. So as I'm looking at the left and right end behavior, make sure that you write it the way I want you to. As x goes to negative infinity, that is, we're looking at negative x values. I know negative 6 is not even close to negative infinity, but it's very evident that this graph is getting more and more negative. So we can confirm that capital F of x is going infinitely down. And then the same thing for the right end behavior. As x goes infinitely to the right, again, I would agree that 6 is not a very large positive number, but it's clear we're going to positive infinity to the right. Okay. Other reasons that I need you to look at this is that the zeros in the table are the only zeros in the function. So that's going to be important when I get to letter C. All right, so that's why I say don't just jump into the problem. Make sure you read all the directions. Now, part B, what must be true about the degree of the function and about the sign of the leading coefficient? Well, based off the end behavior, as x goes to negative infinity, went to negative, the function went infinitely down. So that's a clue with an odd polynomial that the leading coefficient is positive. Again, you can write is positive in case you skipped the first video, which I would not encourage you to do. You should watch all of this. And just a quick, as far as a quick reason, I would re-explain part A. If you want to take it back, like I would prefer to rewrite letter A. But if you wanted to take it back to Algebra 2, where the lame explanation is falling to the left and rise to the right. Oops, rise to the right indicates a positive leading coefficient. There we go. So then let's identify the zeros, and since these are the only zeros, all you have to do is identify where the function equals 0, here and here. So the only zeros that we have are negative 3 and 1. So let's make it like a table, just like we had on the previous problem. I don't typically do this, but negative 3 and 1 are the only ones. So remember, the multiplicities must add up to equal 5. See how I'm setting it up like the tables I had earlier? So the possibilities are really like either 1 and 4, 4 and 1, 2 and 3, or 3 and 2. But earlier in the semester I told you we'll never have a multiplicity of 4. I will not give you a multiplicity of 4. So it's either 3 or 2 or 2 and 3. All right. So what's your indicator of 3 and 2? Now remember, if it's 2, reminder, 2 is a bounces off the x-axis, and 3 crosses. So it's almost like I'm asking you to look at that intermediate value theorem. Is which one crosses the x-axis, going from a negative to a positive versus this one going from a positive to a positive? Well, if you go from a positive to a positive, that bounces. It does not cross the x-axis. There's no negative there. So that tells me that x equals 1 had a multiplicity of 2, and x equals negative 3, going from a negative to a positive, had a multiplicity that crosses the x-axis. So something along those lines, that this one, let's switch colors again, this one crosses the x-axis. Some of you might actually write it goes from a negative to a positive, whereas this one bounces off the x-axis. Or maybe somebody would say it goes from a positive to a positive. There's no indicator that it crosses. Something along those lines. All right, so pause the video, make sure you feel comfortable with your justifications. You can even try the next one on your own. And I'm going to move to the next page. Start going through it. Again, strongly suggest you read the directions. This time it just tells you it's a polynomial. The zeros in the table are the only zeros. And then they even tell you no zeros have a multiplicity greater than 2. Because they don't give you the name of the polynomial. Because what somebody might do is give a multiplicity that's ridiculously high, and that's not what we're looking for. Okay, but before we get into that, let's make sure we can state the left and right end behavior. And for the sake of timing, again, this is sort of unconventional, but if you look at both end behaviors are the same, we're going to positive numbers. So we can then say that g of x is going infinitely up. So think about what that indicates for your end behavior and the degree of your function. So first of all, the leading coefficient must be positive. And again, I would go back to this explanation as my justification. But just to give you a different reason is, both ends rise, which is your indicator that it is, first of all, a positive leading coefficient, and so this implies, this is my symbol for implies, if both ends rise, that means that we have the same end behavior, which means that we have an even degree function. That's the other part of the problem. Now, as we look at the degree that we have and we examine, maybe I'll change colors one more time, our zeros, because these are the only zeros, one of these better have a multiplicity greater than 1. And you might be saying, oh, why? Well, if these are the only zeros, then and they all had a multiplicity of 1, then it would be a cubic polynomial, an odd degree polynomial. Well, we just explained why it was even. So as we then look at the numbers on either side, I'm looking at a positive to a positive. So what's the clue on that problem? If it goes from a positive to a positive, it has a multiplicity of 2. Well, this one, and again, remember, it's none of them are greater than 2, and I will not give you a problem that has a multiplicity of 4. That's just beyond the scope of this class. So then as we look at the next one, we go from a positive to a negative, so that's a multiplicity of 1, you don't have to write that, and then a negative to a positive, so that has a multiplicity of 1 as well. So now we can deduce that it's more specifically a quartic polynomial. And I'm kind of answering part C as well. Because the sum of the multiplicities is 4. So let me just change colors one more time, and I'll do it the same way I did the previous problem. Zeros and their multiplicities So -3 had a multiplicity of 2, -1 had a multiplicity of 1, and 2 had a multiplicity of 1. And again, some sort of justification, how I talked about how this one bounces, or if you say a positive to a positive. This one crosses. And this crossing goes from a positive to a negative, whereas at x equals 2, the way it crosses is going from a negative to a positive. So again, pause the video, make sure you understand. Write something down if you have a question, and we can come back to it when I see you in class, or you can email me. So now we're kind of at a point where we can start practice sketching graphs, and piecing everything together. And yeah, I think I'll at least get you somewhat going on this. Is look for a greatest common factor, which I would do with this -2, x squared plus 4x plus 4. So then as I look at this, I would look at factors of 4 that add to be 4, that's 2 and 2. So instead of writing x plus 2 twice, I would write x plus 2 squared. So what that's an indicator of is, whoops, I forgot to factor out an x as well. I'm sure some of you were thinking that. Is that we have zeros at 0 and at x equals -2. Now this x equals -2 has a multiplicity of 2. And I know that from this exponent. So as I jot down my zeros and x equals 0, I need to cross, well, maybe I should start with the end behavior. We have a negative leading coefficient. So with a negative leading coefficient, that's my clue that my end behavior has to go up and to the left and down and to the right. And having a multiplicity of 2 at x equals -2 tells me it has to bounce off the x-axis there. And then it has to cross at x equals 0. I hope I explained everything. I went back and redid this. As you could tell, I accidentally did it wrong the first time. Whereas as I look at the next problem, I have a positive leading coefficient, still with an odd degree. So I know it's going to go, I'm just going to write it way off to the side like this. The opposite of this end behavior. So what I would do when I'm factoring this, because there's 4 terms, I would start by grouping. The first term has an x squared shared between the first 2 terms. So we're looking at 2x plus 3. And then this one, we have a 9, a -9 that goes into both, because I want a positive term in there. So 9 times 2 gives me 18, and then 9 times 3. And I know I did that correctly because then I could rewrite that as x squared minus 9, and then 2x plus 3. I hope you remember this from Algebra 2. And I would actually notice the difference of squares as the front. We have an x plus 3, x minus 3, and 2x plus 3. Might as well talk about it, and it's pretty important. This is actually, this -27 is actually your indicator of the y-intercept. And I hope that makes sense, because your y-intercept is when x equals 0. Well, if x is 0 in all these values, you're going to get -27. So that might help some of you graph as well, that it's going to go all the way down to 0, -27. So as you look at your other zeros, we have -3, multiplicity is 1, 3, and if you solve this setting it equal to 0, you'll get -3 halves, which is about -1.5, and positive 3. So you can confirm as I draw this graph then, it'll go infinitely down, and I don't know how high this goes up. Finding a table of values would make this better. I'm going to imagine that it goes like further down, and then goes back up at x equals 3. So pause the video And I will make one more to finish these notes.